So let's use some shifts and translations to sketch a graph like this one. F of x equals -1 plus the logarithm base 2 of the quantity x minus 2. What does that mean? Well, if we're using the shift and translation, you recall that we would say if we had a function f of x and we shifted it, and we changed it by subtracting 2 from x and adding -1, that would indicate a shift downward of 1 and a shift to the right of 2. So there's a relationship right here. Remember, we said, well, if g of x is a function that takes a basic function f of x, and we add -1 to it, and we take that function and we subtract 2 inside of x for it, we're going to shift right 2, and we're going to shift down 1. Well, now these two things become important. Let me point out a couple of things right here. Going back to our original graph, we're using a base 2 logarithm. So if we remember the logarithm base 2 graph, it's the kind of graph that passes the point 1, 0 normally with no shift or translation, passes to the point 2, 1, and would also pass to the point 1/2, -1. Not only that, but it would have a vertical asymptote at x equals 0, bear that in mind, and it would have a domain that would go from x equals 0 to infinity. In other words, it would be all real numbers to the right of 0. All right, what is this going to do? Well, if we shift every point down 1 and right 2, let's try that out. We take the point 1, 0, we shift down 1, and we go to the right 2. So our new function will pass through the point 3, -1. Previously, our graph shifted, was at 2, 1. So if we shift down 1 and to the right 2, that means that instead of passing through 2, 1, we would go down 1 to the right 2, and we would pass through the point 4, 0. And finally, if our graph passed through 1/2, -1, that would mean that we would start at 1/2, -1, shift down 1 to -2, and come to the right 2. Well, 2 points to the right of 1/2 is the number 5/2, and 1 point below -1 is -2. Well, it seems kind of weird, but all right. What about our vertical asymptote? Well, if we have a shift to the right, it also comes to the right, and so our vertical asymptote would be found at the point x equals 2 this time. So we're going to sketch that in with a dashed line for our new location of our vertical asymptote, and it's important to note that in our graph. And finally, our domain for this function is going to be the set of all x greater than 2. Now, how do we know that? Well, remember, to find the domain of one of these logarithmic functions, we're going to set the argument x minus 2 greater than 0, and that gives us x greater than 2 as the domain. So 2 to infinity is how we're going to sketch this. And so our graph will come along this vertical asymptote at x equals 2, pass through our 3 points, and then, let's see, if we go through 1, 2, 3, 4, come up one more. I'm going to go ahead and just start selecting points that would go along right here. These points would give us our sketch right here, right? And it's not that hard to see what's going on. A couple of just other quick points that we could use. For one thing, note that the vertical asymptote changed position from x equals 0 to x equals 2. How do I know to do that? Well, in a logarithmic function, we set the argument equal to 0 to find the location of the vertical asymptote. And so it goes along with the location of our domain. Vertical asymptote is found by setting the argument equal to 0 and then using that. So a couple of points right here, very easy to get if you recall what that original graph looked like. And then you shift and translate based on it. All right, good luck with your graphs.